Hello, this is the video for preview video for multi-compartment kinetics. It's the second one. This is going to be a very quick video, I hope, because I will just briefly explain 2 or 3 concepts. As you remember in the class, I was talking about the central compartment volume is smaller than peripheral compartment. And based on this assumption, we have made some calculations too. For example, we have calculated VC using a volume distribution dose by A plus B. And also we have calculated AUC based on this equation, A by alpha plus B by beta. So this part of the preview only deals with the assumption, incorrect assumption. If, for example, we ignore this part, what will be the consequences? We calculate volume distribution using this, and I have already explained in an assignment. For example, here we know our by exponential fall of concentration, this is distribution phase and this is elimination phase. Or better curve would be, this is distribution, this is elimination. So now one person who is not familiar with multi-compartment kinetics, or you do not know the kinetics of the drug, either multi-compartment or single compartment, so you just use a best fit. Best fit most of the time will give you a big elimination rate constant, which will be very close to the terminal rate constant. That means most of the time you use this phase, beta. So what will be the consequences? That's what this part of the preview deals with. First, as you see, this is the correct one. You have to take both phases into consideration. You have to take alpha and beta. Here, that's why it is AUC is this. And also, in calculation of volume distribution, we have to use this. All these words is just for explanation purpose. If you understand this, you don't have to read the note. So what happens if you do not follow this rule? So you are using only, instead of, you calculate VC is dose by B, and AUC you calculate B by beta. So here this curve is showing nothing but that you assumed it's wrong assumption. You are just using one curve, so you are using beta, and here it is showing that how volume distribution increases with time. So volume increases, and then the peripheral volume distribution is higher. So now this would call, if this would be called incorrect AUC. If we do not consider it, this part, A by alpha, the correct AUC is this, A by alpha plus B by beta. So you do not consider this, then this would be called incorrect AUC. Incorrect AUC. And same is in case of volume distribution. You do not use dose A plus B, you just this part, B. So this will be your incorrect volume distribution. In this case, to person error, you can calculate by this equation. And I have, in the assignment video, I have explained a lot about it, that how you have to do that calculation. So now assume that you have calculated, you have used wrong volume distribution. You see here, correct volume distribution is what? correct volume distribution, VC correct would be dose A plus B, and then VC incorrect dose plus B. So which one is going to be? This volume distribution will be B, because you know that this you will have one parameter, so this is going to be, so for incorrect volume distribution is going to be inflated or overestimated. And if you use this volume distribution to calculate clearance, which is K by V, you clearance will also you will overestimate because you are using a larger volume distribution. So and you also know how to calculate dose. We know that V is equal to dose by C0. So now if you have an incorrect volume distribution, for example, you use this volume distribution which is going to be larger, your dose is going to be high because V times dose. So your your loading dose is going to be high in case of incorrect distribution. So all this I was trying to explain what's happening here. Let's close this. So anyway, because of this, as you will see, if you use my loading dose, correct loading dose, there will be correct loading dose which is V, use this correct loading dose using, sorry, if you use one of them, for example, if you use my VC dose by A or VB dose by B, so if you use my VC, as A is always very big, so your volume distribution is going to be small. So here you see this loading dose based on is barely hits the target therapeutic concentration. In case of if we use loading dose based on this will loading dose will exceed a little bit, exceed the therapeutic target. So again, let's go back. Correct VC correct is dose by A plus B, and V incorrect would be dose by B. So when you use this one to calculate dose, you will have a higher dose, and this would be your correct dose. So for this reason, when the drugs that shows multi-compartmental model, multi-compartmental kinetics, for example, one of the example I am giving is Digoxin. Digoxin, you see here, Digoxin takes about 6 hours after the IV and 8 hours to reach the pseudo equilibrium. You see here, this is your pseudo equilibrium. Digoxin take about 6 to 10 hours to come to equilibrium. So if you take sample from this during this time period, that means, you know, in our figure we are showing small and large compartment, as these are hypothetical compartment. So think about the drug action is in this compartment. Drugs is producing its action in this compartment, but you are collecting sample from here. So that means this will give you an inaccurate idea about the therapeutic concentration or therapeutic dose of the drug. So again, this is not that hard. If I have not confused you, first let's do this. This is time and drug concentration, and this is the profile. And we know this is central compartment and this is peripheral compartment. Drug acts here and does not act here, ineffective here. So now you are taking sample from here, then it would not give you an idea about the therapeutic efficacy, therapeutic concentration. So in that case you have to take sample from there, but we do not have physiological compartment. These are hypothetical compartment. So what you have to do, this compartment is based on the time. So we know digoxin, it takes 6 to 10 hours to distribute, and then it goes to the peripheral compartment. So for this reason you have to collect sample during this time, this period, to monitor therapeutic efficacy of digoxin. Does this make sense? Now think another drug which is lidocaine. Yes, lidocaine works in the central compartment. Multi-compartment model, lidocaine's drug concentration depends on plasma concentration. That means theoretically it works on central compartment. So but central compartment that means in plasma concentration. So for this reason, as this is we have to take sample for this area, both post distribution and pre-distribution. So here the samples are collected at pre-distribution and post-distribution because effects are related to its plasma concentration. So now we have to collect in both phases, during this phase and after this phase. So again, for digoxin, which works in the peripheral compartment, we have to wait 6 to 10 hours. 6 hours for IV administration, 10 hours for oral administration. And then you take the sample. This will reflect accurate therapeutic concentration in case of digoxin, because digoxin works in the peripheral compartment, but in case of lidocaine, it works in the central compartment, and central compartment, that means in the plasma concentration, reflects its therapeutic efficacy. For this reason, when plasma concentration, this always, you know that these are all plasma concentrations. So for this reason, to keep track of plasma concentration, you take sample here and also there. For in case of drug that works in plasma compartment, central compartment, you take sample during pre and post distribution phase. So here, for example, digoxin, again, if you write digoxin, this question I will always ask. Digoxin, for example, has a half-life of 4 to 6 hours distribution. Digoxin 4 to 6 hour distribution phase after IV and oral administration. And digoxin site of action is the peripheral compartment. So to ensure the plasma concentration reflects concentration at the site of action, plasma serum levels are monitored at least 6 hours after IV dosing, because drug is working during this phase. So you have to take sample from during this time. But in case of lidocaine, works theoretically in the central compartment, but as we cannot monitor central compartment only, so and we have to see the concentration, it cannot go up or down below the plasma concentration. You have to monitor here and also here, before, post, and so I will explain this thing lidocaine issue, but more important is lidocaine samples are taken both at pre-distribution and post, because effects of the drug, because effects of the drug related to its plasma concentration. So theoretically it works in the central compartment. Now what are the possible, explain and understand really why use of terminal data would give you inaccurate AUC, CL and volume distribution. Yes, because we have two phase. The equation says this is A is equal to E to the alpha T plus E to the negative beta T. So if you calculate only, if you have to calculate AUC, you have to use both phase. You have to take AUC of this, that means you have to take AUC of this AUC, and also you have to take AUC of this. You cannot just take this one. So this will give you erroneous data. To if you use this this phase only, you have to do some calculation. Same is true for plasma volume distribution. In case of volume distribution, you have to take both dose and then concentration here, A plus B. If you do not do that, you will have incorrect volume distribution. Why digoxin serum levels are monitored at least 6 hours after? Because digoxin therapeutic effects, digoxin elicits therapeutic effect in peripheral compartment. So that's why and it takes 6 to 8 hours to distribute. So for this reason, when distribution equilibriums arrives, you have to take sample during this time. But lidocaine are collected both pre and post, because lidocaine concentration depends on the plasma concentration. Libo's and lidocaine's therapeutic efficacy depends on plasma concentration. So that's why you have to take pre and post. And these are the calculation. Again, I'm not going to take more time here. You just remember incorrect and correct AUC. And also, if you use incorrect AUC, your volume of distribution would go up, and also clearance will go up. So that means you will have overestimation or inflated V and CL. This concept again I have explained in the video for assignment. I have explained everything in assignment. I hope this helps, and I will briefly go over this on Thursday's class. Then I have to switch to a new lecture. I hope this helped. This is the second video I have recorded today. That's why I have stumbled a lot in this video, but I hope this helps. Thank you guys.